Okay, so today we're going to get into the next section, which is now solving our quadratics using graphing. So yesterday we practiced, and in class we practiced how to graph those. Today we're going to now look at, well, how can I find a solution or solutions to that graph or to that equation? We're going to have a new vocabulary word today, double root, and a double root is when the two roots are the same number. Right, and that happens if you had, for example, from our previous chapter, a perfect square trinomial, you would end up getting the same value for x. When we're looking at this, a couple of things you need to remember. You're going to hear these words over and over again, and we talked about them in our linear equations chapter. But when you hear the word roots, it means the same as x-intercept. It means the same as the zeros, and it means the same as the solutions. So all of those things mean exactly the same word. So if we're talking about the roots and we're in a graphing form, then we're going to be looking at the x-intercept. Where does it cross the x-axis? We're going to have three different types of situations that we can have. Here, if you notice, it intersects the x-axis 2 times, 2 roots, 2 solutions, 2 zeros, 2 x-intercepts. Here, it only hits the x-axis 1 time, and that is going to be an example of a double root. Here, we have no real solutions, because again, you can get into these other things called imaginary, which you're going to learn about in algebra 2. So this one would have no answers. It does not cross the x-axis at all. There's no value for x there. Okay, so when we solve these by graphing, so the first thing you have to do is you have to graph it. We know there's a lot of different ways that you can do that. One of the easiest is you put it into your calculator and then you go to your table. You need some type of work here. So whether it's doing your own table of values, whether it's reading the table of values, whether it is going through, I'm going to go through and do this one using my vertex, my turning point, my axis of symmetry, all of that. So I'm going to start off by finding my axis of symmetry, negative b over 2a. So a, b, c. So b is negative 4, so the negative of a negative 4 is 4. A is 1, 2 times 1 is 2. So I have an axis of symmetry of 2. Then I'm going to put that in to figure out what y is. Notice when you have the 0 and you want it by graphing, your 0 becomes your y. So if you wanted to put that into your calculator, that's what you would be entering. So then this is 2 squared minus 4 times 2 plus 3. So that's going to give me negative 1. So now I know that my turning point is 2, negative 1. I know my y-intercept is 3. So now I can go through and put some of this information on the graph. So when I do that, so I'm going to put my vertex on first at 2, negative 1. I have the y-intercept of 3. And I know right here is my axis of symmetry, which means I need another point. From here, it's 2 away, so I need it to be 2 away on the other side. So even though I don't have 5 points like I'm used to, I have enough to now connect them. And then what I'm going to do is I'm going to read, well, where is it intersecting the x-axis? What are my zeros? So that's the point 1, 0, right? So that would mean x has to be 1. And this is the point 1, 2, it crosses at 3, so x equals 3. Just like when we solve them by graphing, we do need to put those into our set notation, our fancy brackets. So those are your solutions, your roots, your x-intercept, your zeros. All means the same thing. All right, this one, I'm actually going to get and take a table of values for. So when I do that, I first like to always find my axis of symmetry anyway, so that I know where to get my values. One thing we need to notice though, sorry, This is not in standard form. You still need one side to either say y or 0. So I have to subtract 6x first. So we have negative 2x squared minus 6x minus 8 equals 0. So now here's your A, your B, your C. So, excuse me, to get my axis of symmetry, it's actually going to be negative 3/2 is my vertex, so negative b over 2a. So this is going to be 6 over negative 4, which is negative 3/2. I'm going to put that in for y, and I'll tell you right now that it turns out to be negative 7/2. I'm not going to take the time. You can put that in your calculators. So my turning point, my vertex, is negative 3/2, negative 7/2. I know the axis of symmetry is right there, so I'm going to plot this. So this means over 1.5, down 3.5. 1, 2, 3, half. So that's my turning point. My y-intercept is at negative 8. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to just kind of sketch in the axis of symmetry. So that means I know I need a point that's 1.5 on the other side. 1.5. So when I graph this one, right, the one thing that you should notice, it never crosses the x-axis. There are no solutions. Which means when you put it in set notation, it's the empty set, which can also be written like that. Those mean the same thing. Okay, now this is where we're going to have to put in some work, because now it tells you where we're going to approximate the roots with a table. So the first thing I need to do is I need to graph it. Okay, I'm going to just do this one. I'm going to do by a table for graphing, and then we're going to end up making another table. But I do know, first of all, it's in standard form. I do know that my axis of symmetry is going to be, let's see, that's negative 6 over 4. We're going to have another negative 3/2. So when I do that, and my turning point ends up being, this one is also down at negative 7/2. Is this the same? No, never mind, sorry. Y ends up being, not negative 7/2, negative 7.5. So when I'm looking at this, and my C, or my y-intercept, is 0, negative 3. So my axis of symmetry is right about here again. I'm going to put my points on. So we have negative 1.5, negative 7/2, which is way down here. I have my y-intercept is negative 3, which means I need one right over on the other side. So when I do this, you're going to notice that these are not lining up on one exact point. I know over here it's somewhere between negative 4 and negative 3. I didn't do that very well. And on this side, it's somewhere between 0 and 1. So then what we're going to do is we're going to use some approximation to try to figure out what that number is. So I'm going to work on this one that's between, this should really be between negative 4 and negative 3. So I'm going to start by putting in some values for x. And this is going to be all calculator work. I'm going to go up by tenths. So I need negative 3.9, negative 3.8, negative 3.7. I ran out of room, negative 3.6. And we're going to be looking for the value that is closest to 0. Because remember, that's what we want, right? When we want to know, well, what is it when y is 0? So we're going to be looking for that. When I did this on my calculator, just to save time, so I took all of these and put them into my original equation, all calculator work. This ends up being 4.02, 3.08, 2.18, 1.32, 0.5, negative 0.28. As soon as I saw that this now went from positive to negative, I knew my turning point had to be somewhere in here. Because that's, again, that's where it starts to turn. So I'm going to look at these two values and be like, okay, which one is closer to 0? And then I'm going to use that x value is going to be one of my solutions. So negative 0.28 is closer than 0.5. So I'm going to use this x value. It's an approximation. All right, so I can say x approximately is 2 wiggles, negative 3.4. So that's one of the solutions. Now I'm going to do the same thing on the other side. I know it's somewhere between 0 and 1, so I'm again going to pick, I'm going to go up by tenths, and I'm going to pick values of x and do some calculator work. So I'm going to start with 0.1, 0.2, 0.3, 0.4, 0.5, and so on. So let's see what we get here. Again, I did it all in the calculator earlier just to save some time. So we have negative 2.38, negative 1.72, negative 1.02. So we're still negatives. We're getting closer to 0. Negative 0.28, and then positive 5. Well, again, I'm looking for, here's where it changed. And then I have this one is closer to 0. So my other approximation is 0.4. So my solutions, my zeros, my roots, are negative 3.4 and 4, approximately. Okay, so we're going to take what we used before, graphing, whether you put it into a table, but if you end up with a axis of symmetry that's a fraction, then you're going to have to change your table if you're going to use your table of values. Otherwise, you can create your own and do it from there. So let me just kind of do this here. A goalie kicks a soccer ball with an upward velocity of 65 feet per second, and her foot meets the ball 1 foot off the ground. This is the function that represents it, right? H is talking about how high it is. T is talking about your the time. Approximately how long is the ball in the air? So what we're looking at, if I were to graph this, okay, and I did this again. I put this one in my calculator and I just kind of copied the graph. But the graph basically looks like this. Right? These are our seconds. Oh, I did not count that out right. Oh, yeah, I did. Sorry. These are our seconds, 1, 2, 3, 4. And again, I read this off of my graph. I put it in the calculator, copied the graph a little bit, and then wrote that down. So how long is the ball in the air? Well, it's how many seconds. It starts here, and it's in the air, in the air, in the air, on the ground again. So the number of seconds, it went from 0 to 4 seconds. So how long is the ball in the air? 4 seconds. So that's using a real-life situation in its graph to help us solve it. So again, the biggest thing right here is when we're solving, we're looking for the x-intercepts when we're doing this off of a graph. Called a bunch of different things. Roots, zeros, solutions, it's the x-intercept. If you can read it directly off the graph, great. If you can't, then you have to approximate it by going by tenths, putting in numbers and seeing which one is closest to 0, and then that's your x value. All right, so that's kind of it in a nutshell. Any questions, make sure you write them down, bring them to class, and have a good night.